In Unit 4, we looked at triangles and types of triangles, different properties and theorems about triangles, and how to apply those theorems and properties. So the first thing we did was we looked at classifying triangles by their type, by sides, and by angles. So when we say an equilateral triangle, it means a triangle that has all three sides are equal. And as long as all three sides are equal, all three angles are also equal. So this is also called an equiangular triangle. When we had an isosceles triangle, we had two congruent legs, which also means that the angles opposite those legs have to be congruent as well. A scalene triangle is when we have all three sides are not the same, so no congruent sides. And then a right triangle means that we have exactly one right angle. So the next thing we did was we looked at coordinate proofs. So basically proving that a triangle is equilateral or isosceles, or an isosceles right triangle, a right triangle, or a scalene triangle. So here are the different steps to do each of those to prove that it's equilateral, isosceles, scalene, a right triangle. You can use the distance formula for all of these. Keep in mind for number 4 here, showing that a triangle is a right triangle, you can use slope formula to show that the two sides that form the right angle are negative reciprocal slopes, meaning they're perpendicular. Or another way is to use the distance formula. And if you use the distance formula and find the length of all three sides, what you can do is then plug those three lengths into the Pythagorean theorem and make sure that it checks out. If it checks out, then we have a right triangle. Otherwise, you do not have a right triangle. So there's two ways of doing that. The other three, equilateral, isosceles, and scalene, you just use the distance formula to show however many sides you need to be congruent. So let's look at some examples using this vocab with the different types of triangles. So in this diagram here, we have AB and AC are congruent. So right away I know that this triangle here, ABC, is isosceles, which means that these base angles have to be congruent. I also know that the measure of angle A is 30, so we can label that. And I'm trying to figure out the measure of angle ACD, so this exterior angle here. So what I can do is, since all three angles in a triangle have to add up to 180, if I call each of these base angles x because they are equal, x plus 30 must equal 180. So we have 2x plus 30 equals 180. Subtract 30 from both sides, we get 2x equals 150. Divide each side by 2, we get x equals 75. So each of these angles has to be 75. Another way of figuring that out is just by taking 180 minus 30, and you get 150, and then divide your result by 2, since we know those two base angles have to be equal. And then the next step here is to make sure that we actually find the missing angle, which is angle ACD. So I know that this 75-degree angle and this exterior angle have to add up to 180 because they form a straight line. So what I can do is just do 180 minus 75, and we get 105. So the measure of angle ACD is 105 degrees. Let's look at this next example here. So in this case, it tells me that I have these two congruent base angles. So right away, I know that this has to be an isosceles triangle, and the sides opposite those base angles must also be congruent. So now what I can do is to find the length of BC is the relationship between these two sides is that they must be equal. So I'm going to go ahead and I'm going to set them equal to each other. So 5x minus 10. And we're going to just solve this equation for x. So they gave me the two lengths. I'm setting them equal because I have an isosceles triangle, and I need to find the length of BC. So go ahead and solve this. So bring the 3x over. So we have negative 2. When I subtracted the 3x from both sides, I have 2x minus 10. Add the 10 to both sides. So we have 8 equals 2x. Divide both sides by 2. So we get x equals 4. Now, we're not done when we say x equals 4 because the question says find the length of BC, which means you need to plug in. So you're going to plug in, and you'll get 20 minus 10, which gives you 10. So the answer is BC equals 10. Make sure you're careful that you answer that, because especially if this is a multiple choice question, this answer of x equals 4 will definitely be one of your options. So just make sure you read the question and that you always make sure that you actually answer what it's asking you to do, which in this case is not just to find x, but to find the length of side BC. The next thing that we looked at when we talked about triangles is the sum of the interior angles. So we know that the sum of the interior angles of a triangle is always 180. So all three angles have to add up to 180. So if you look at this example, we have the measures of angles in a triangle are in the ratio of 2 to 3 to 5. So whenever you see this ratio, automatically you should be thinking the angles are 2x, 3x, and 5x. X, we have to use X because there's this common factor between the three angles. That's why it's the ratio is 2 to 3 to 5. It's not the measure is 2 degrees, 3 degrees, and 5 degrees. So you have to put the X in there because you're trying to find that common number being used. So we're trying to find what is the measure of the largest angle of the triangle. So basically I have some triangle and I have, let's say, 2x, 3x, and 5x. And we know that these three angles have to add up to 180 because they're the angles in a triangle. So combine like terms. So we have 2x plus 3x plus 5x gives us 10x. Divide both sides by 10, so we get x equals 18. And again, make sure that you answer the question. The question doesn't ask you to find x, it asks you to find the largest angle. So in order to find the largest angle, that's going to be this 5x, because that is the biggest number that you'd be multiplying by. So the largest angle is going to be 5 times whatever we get out for x, which is 18. So 5 times 18 gives me 90 degrees. So you don't have to find all of the others. If you wanted to check your work, you could, and then make sure that all three angles add up to 180. But in this case, we can just say, okay, well, 5 times 18 and we get 90. The next theorem dealing with angles in a triangle is the exterior angle theorem. So to kind of show you what this is, we come up with this picture where we extend one of the angles in a triangle. So if I have a triangle, this angle on the outside is the exterior angle. And the rule is that the two non-adjacent angles have to add up to equal this outside angle. So that means the measure of angle 1 plus the measure of angle 2 must equal the measure of this angle 3. So to look at an example of that, in the diagram below of triangle ABC, side BC is extended to point D. The measure of angle A is x. The measure of angle B is 2x plus 15. And the measure of angle ACD is 5x plus 5. What is the measure of angle B? So that means I'm going to have to find x first and then plug back in. So our relationship is going to be that these two non-adjacent angles have to add up to equal the exterior. And when we say non-adjacent, we mean the angle that's not touching this exterior angle. So we can't ever use this angle here. So our relationship is going to be x plus 2x plus 15 equals 5x plus 5. And then we just solve it for x. So combine like terms first. So we have 3x plus 15 equals 5x plus 5. Subtract over this 3x. So 15 equals 2x plus 5. Bring the 5 over. So 10 equals 2x. Divide both sides by 2. We get 5 equals x. Again, make sure you go back and answer the question. The question asks for the measure of angle B. So that means I have to take what expression represents B and plug in 5. So the measure of angle B is going to be 10 plus 15. So we get 25 degrees. And again, if this were a multiple choice question, you would see 5 in your answers as well as 25 in your selection to choose from. So always make sure you actually answer the question they're asking you to. Another theorem that we talked about was dealing with the sides. So we talked about the interior angles adding up to 180, the exterior angle theorem, and then we talked about the relationship of the sides of a triangle. the triangle inequality, there's two things here. And the first thing that we have to know is the actual inequality, that the sum of any two sides of a triangle must be greater than the third side. So basically, if they give you a set of numbers, so let's say you were given 5, 5, and 10. These three numbers would not form a triangle because 5 plus 5 is not greater than 10. The sum of any two sides have to be greater than the 10, or greater than the third. So even though 5 plus 10 is greater than 5, it works for that case. Any two that we choose, it's not always going to work. So you have to basically take the set of numbers and pick any two sides, add them up, make sure that they're always greater than the third in order for those sides to form a triangle. So the other way of figuring this out is using the formula. So basically, the formula says that the third side of a triangle has to be less than the sum of the two other numbers, but greater than the difference. So basically what that looks like, we will use that for this example here. If the lengths of two sides of a triangle are 3 and 6, find the possible integer lengths of the third side. So when you don't have a multiple choice question with a set of three numbers already provided and you're just trying to decide if they form a triangle or not, this is kind of the approach you're going to use. You're going to use the second part of the theorem. So basically what you do is you take the two numbers they give you. So they give you 3 and 6, so you add them. We get 9, and you subtract them, and you have to do big minus small so that you don't get negative numbers. And the third side has to be between the sum and the difference. So it has to be less than the sum, so less than 9, but it has to be greater than the difference, which is 3. So that means this would be the inequality version. The third side has to be greater than 3 but less than 9. But since it says find the possible integer lengths, that means that we want whole number values or integer values. So that means we'd actually list them out. So you can't have decimals. So the first length that you could have would be 4, then 5, 6, 7, and 8. And we can't include 3 or 9 because you have to be greater than 3 but less than 9. And since it says integer lengths, that's why I'm not including like 3.1. I'm not including decimals because of the way the question's worded. So it depends on the question. If it says write an inequality, it would be left like this. If it says to list integer values, then you actually list the numbers. And then the other important theorem that you all know has to deal with the sides of a triangle is the Pythagorean Theorem. So this is a squared plus b squared equals c squared. And this is for the sides of a right triangle. So a and b can be the legs. C is always the side across from the right angle, which is the hypotenuse. And the Pythagorean theorem can be used for two things: finding the missing side of a right triangle, and it can only be used for right triangles, or it can be used to check to see if you have a right triangle. So you can use it to determine if a triangle is a right triangle. So basically, in order for a triangle to be a right triangle, it has to work in the Pythagorean theorem. So say we have three numbers, I would plug them in, making sure that the biggest side goes in for C. I'd plug them into a squared plus b squared equals c squared and see if it actually works. If it works, that means you have a right triangle. If it doesn't work, that means you don't have a right triangle. So this is a great way to do a coordinate proof for proving that you have a right triangle, because if you find the length of all three sides of a triangle on a graph, then you just plug them into the Pythagorean theorem. If it works, then you have a right triangle. If it doesn't work, you don't have a right triangle. But most commonly, it's used to find one of the missing sides given the other two. The next thing we talked about was a mid-segment. So a mid-segment's a special segment in a triangle. So a mid-segment, let's just look at a picture, is a segment that connects to the midpoints of a triangle. So this segment here would be the mid-segment, and these two sides would be congruent. So it connects to two midpoints. So the definition is a segment that connects to the midpoints. It has to connect to two midpoints, not just one. If it connects to one, then it's a median. And the properties. So it's parallel to the opposite side. And it's half the length of the opposite side. So when we look at these examples with mid-segments, a lot of times you're going to be using this half the length of the opposite side. So this example here says, in the diagram below of triangle ACT, D is the midpoint of AC, O is the midpoint of AT, and G is the midpoint of CT. So basically, I know that all of these segments that are drawn are mid-segments because they connect to midpoints. And then it tells us that AC is 10, AT is 18, and CT is 22. It asks us to find the perimeter of this parallelogram CDOG. So I have to know the length of all of the sides of this parallelogram so that I can find the perimeter. So what you're going to do is, since you have all of these mid-segments, these are all mid-segments, I know that, say, DO is half the length of the side across from it. So if this whole side is 22, DO has to be 11. I also know that since G is the midpoint of this side, this piece here has to be 11. Each of these sides has to be congruent, or each of these segments has to be congruent, because G is the midpoint. And then I can use the same idea over here. Since D is the midpoint of segment AC, this piece has to be 5, as well as this piece up here. And I also know that OG has to be 5 because it's the mid-segment and it's across from the side length of 10. So then I would just add these up. So 5 plus 11 plus 5 plus 11. So the perimeter of CDOG is going to be 32. And the last page here, we have some more vocab about special line segments and triangles. I'm just going to go through and draw a picture of for each of these. So first one here, we have a median. So when we're talking about the median of a triangle, it connects from the vertex to the midpoint of the opposite side. So vertex to midpoint. Let me just write like quickly, vertex to midpoint. So that's the key thing here. Mid-segments have to connect to two midpoints. Medians go from the vertex to the midpoint. So it doesn't have to be perpendicular, it just has to connect to the midpoint. What makes an altitude is that it goes from the vertex and perpendicular to the opposite side. So it's vertex and perpendicular to the opposite side. An angle bisector just has to go from the vertex to the opposite side so that it cuts the angles in half. So it has to it doesn't matter where it crosses over here, but it has to go from the vertex to the opposite side and cut the angles in half. To opposite side, cuts angle in half. And then the last one, perpendicular bisector. So the perpendicular bisector is kind of the unique one because the perpendicular bisector does not have to go through the vertex. So if I wanted to draw the perpendicular bisector, first thing I do is I locate the midpoint, and then I draw a line so that it is perpendicular to that opposite side. So it does not have to cross through the vertex. However, it can, like in this case, when I draw the midpoint and a line that's perpendicular, it just so happens that it does cross through the vertex. So it has to be perpendicular to the side, and pass through midpoint. Does not have to cross through midpoint, or does not have to cross through vertex. Does not need to pass through vertex. It can sometimes, but it doesn't have to. It does have to pass through the midpoint, though. That's what gives it the bisect part. This chart down here just kind of talks about those points of concurrency. Remember, every single triangle has 3 of each of these segments, so 3 perpendicular bisectors, 3 medians, 3 angle bisectors, and 3 altitudes. When those segments cross, these are the names for them. And each of these has a special property except for where the altitudes cross. There's no special property. So this is just something that you want to read through and make sure you know. But let's go ahead and just look at an example of using the segments as well as an example of these concurrency points. So this example here, we're given triangle ABC and we want to make some conclusions. So basically I'm going to just go through and make conclusions based on each one of these segments. So BF is a median, which means I have 2 congruent segments. So I have this segment and I have segment FC. So from the median, I have AF is congruent to CF. So this is something that you would use in a proof. If they tell you BF is a median, you'd be able to say, well, AF is congruent to CF because a median implies 2 congruent segments. And then you can say, well, the next one here, I have an altitude. So number 2, using the altitude. So if BD is an altitude, it's perpendicular to the opposite side. So I can say BD is perpendicular to AC because altitudes imply perpendicular lines. Now you could go further and say you have right angles, but basically once you know you get perpendicular lines, then you can imply the right angles after that. And the other one here that we have is BE bisects angle ABC. So angle ABC is being bisected by BE, which means that I get 2 congruent angles. And the angles that I get are congruent are angles ABE, so ABE, and CBE, angle CBE. And these are congruent because an angle bisector implies 2 congruent angles. Just be careful too that you look at where is that angle bisector, and it's the angles that are formed when that segment is there. So those are just kind of things that you might see in proofs. So this was number 3. So if you see any of these segments, those are some conclusions you can make. And the last one here is talking about the medians. So I have the medians are all drawn. So I know that all of these points here are midpoints because medians go from the vertex to the midpoint. I also know that G is the centroid because it's where all the medians cross. So G is the centroid. And that means that 2/3 rule applies, or that 2 to 1 or 2 to 1 ratio applies. So if the length of FG is 20, that means that GC has to be twice as big. So GC has to be 40. You can also think of it as that 2/3 ratio. So GC has to be 2/3 of this entire thing. So since this entire thing would then have to be 60, GC is actually 2/3 of it. So it's always split up into the ratio of this piece is 2 times as big as this piece here, or this is 1 times the size of 1/2 the size of this piece here.